Today, Evey number 7, the one where we finally get the camshafts installed, and we'll run it on the bench. No horsepower numbers today, but we will at least see how it runs and how lumpy it idles. Let's get into it. All right, and in order to get the camshafts in there, first we got to make sure that we're not going to have some intimate contact between the valves and the pistons. So in order to do that, we've got a whole bunch of checking to do first, and let's take a look at that. So how we're going to do that is I'm going to take all the rockers out of the engine, and I'm going to take this post, I'm going to make an adjuster so that this becomes a solid lash adjuster. I'm going to put one rocker in, either on the intake or the exhaust side, combined with one of these springs. This just makes it so I don't have to fight the spring as hard. And we're going to be able to figure out at what angle does the valve hit the piston, and then from there, we're going to use this lovely degree wheel, figure out exactly where we got to put our center line so that the VVTI, when it goes from one side to the other, doesn't cause us clearance issues. I want to make it so ideally, no matter what position this is in, it's not going to interfere. We might find that we have to make some compromises on that, and if that's the case, well then we'll do it, but my goal is definitely not to have to compromise on that. So first things first, it means we got to pull the valve cover off, pull the timing cover off, and we should be able to do this technically with only the valve cover off, but since we're going to be messing with the timing assembly so much, it'll be easier if I just pull the valve cover off also. And on this engine, that's all I need to do is just those two covers, well, and the crank pulley. And then we'll be in there and we'll take a look at it. So let me take it apart. We'll get right back to you guys. So I have to apologize. There's obviously a continuity change from where you just saw a second ago to now, and that's because I threw out a whole bunch of footage. I reviewed it, and I had forgotten to turn the lights on that you guys see that make it significantly brighter in here. It was just all washed out, and the footage wasn't framed properly, and it was mostly me just riding the struggle bus, trying to figure out exactly where these cams need to go. So let's back up a couple steps. As you saw, I put the lightweight springs in there, and then I was going to use this guy right here to be able to make a fixed position post in order to not have any lash in the valves so that I can check for clearance. Instead, what I did, because this ends up starting too tall, you can kind of barely see it there. So what I did is I mounted one of these in the OD grinder, and I just ground the bottom off a tiny little bit. Effectively, these have a really strong spring in them, so effectively with the lightweight valve spring on here, this is solid. It's as solid as it needs to be anyways. So right now, I have the rocker on the number 1 valve on the exhaust side, and I did the math. You can see there's a mark right there. You may or may not be able to see it, but it's 15 teeth advanced. 15 teeth retarded from the timing mark on here, but that's intentional, right? Because these camshafts are actually exactly the same camshaft. I put the pin for the intake where it belongs. The pin on the exhaust side had to compromise. Now, that's not going to be the way it is for production, because that's going to screw up the timing marks in the back. The intake and the exhaust cam will actually be separate part numbers, but both will have the ability to be used in the opposite position if for some reason that makes sense for somebody. It can be used, because this motor will run either phaser in either position. I can't imagine why you'd want to run 2 exhaust phasers, but it doesn't matter. It costs me literally nothing to put the feature in, so you guys can have at it. The other thing I did, I took this spring here, right here. I took that out of the exhaust phaser, and that makes it so that it's easier to check the phasing on this cam. So as you can see right now, well, I'm going fast because I know there's no clearance issues. So what we're going to do now is I'm going to show you guys what the clearance is in the worst case. So we're going to retard this cam as far as it'll go, and then we'll check for clearance at top dead center, because top dead center is always where the worst case scenario is going to be. I also did the math. I confirmed that in math. Top dead center is going to be the worst. So let me go ahead and release that. Oh, and a design change that I noticed. The hex is a little too precise. I need to undersize the hex by like 15 thousandths so that you can actually get a wrench on there easily. It's kind of stiff. All right, so as you can see, our cam is released right now, so that this moves without this moving. Yeah, max retard, so pulling it this way towards the intake. And now we're going to kind of have to be gentle about this so that it doesn't go over the top and slam shut. All right, so let's go to TDC. So here's TDC, and let me get you guys in with the GoPro. All right, and we're in here, and I don't know how well you can see that rocker there, but I'm touching it with the screwdriver, and as you can see how the screwdriver can move up and down? We are not touching the piston. So with having this 20 degrees advanced further than what it intends, it gives us most of the angle that we need. It'll give us 22 out of the 25 degrees that we need, and it clears the piston. So let's take a look at the intake. All right, so we're gonna lock our exhaust cam back in. There it is. Come on, give me the wrench. There you go. So now that's locked back in, and we're gonna have to take this all apart to move the reduced length lash adjuster over to the intake side and the rocker as well. So let me go ahead and do that real quick. And by the way, I actually haven't checked the intake side yet. I did some preliminary checks yesterday, but I'm not redoing this on camera for you guys. I actually haven't done it. So this one, we'll put an indicator on it and everything and measure how much travel it has. All right, so our timing mark is aligned on the intake. It's not on the exhaust, but it doesn't matter because there's not even a single rocker in there. All right, so what we're gonna do now, we have to move the cam at full advance, so that's clockwise, and then make sure we've got clearance. So let's go ahead and do that. And by the way, to release these, you're blocking the big port right here. You're feeding pressure into this port, and then with my arm, I'm pushing in the direction that it needs to go. There it is. And all you're doing is you're providing pressure to release the locking pin. So now, as I said, I haven't actually done this one yet, so I need to do this a little bit slow. Okay, and now the piston is coming back up. Oh, we actually skipped over it. On the exhaust, the problem area is on the backside ramp. On the intake, it's on the front side, which we already did, but we're gonna have to go all the way around, come back to it. because I was just looking like it was at 90 degrees from top dead center. That didn't make any sense. Okay, so it should be this one right here. So the good news is we're clearing. Let's see by how much we're clearing. First, I'm just going to give it kind of an eyeball test by pushing it. That's a problem. Looks like my lash adjuster has moved. Okay, I'm going to put this back to lock. Oh, sure enough, the latch adjuster has moved. That's annoying. Okay, give me a second. I got to lock that up. Oh, yeah, sure enough, it has unlocked itself. That's annoying. Well, nothing a welder can't fix. And there, now we have a solid lifter. All right, it isn't moving. So let's go ahead and unlock our cam again. There we go. All right, and we're almost at the point where we want to be. So let's hope we don't have contact. Oh. Yep. Well, that's frustrating. So, looks like right about here, 3-4 degrees before top dead center, things contact. Which means by the time you figure in for clearances, we actually probably need to be over by 10 degrees. So, well, this is relatively easy to fix on the production cams. I'll do some more precise measuring. I'll do some more precise measurements, but this is relatively easy to fix on the production cams. It's simply a question of static retard of about 10 degrees on the intake cam, and that's not a big deal, nor is it unexpected. In fact, that's kind of why I'm doing all this. That leaves me with two choices now. Choice number one is to leave it as is, and that still gives me about 30 degrees of potential advance on the intake cam. Option number two would be to advance this by a whole tooth. Now, what that would limit my ability to advance this even further. Normally we run about 30 degrees of advance at the peak, but the peak is around 4,000 RPM or so. So we'd lose, again, just like over here, we lost some power right around there. We'll lose some power here. Now, in theory, by doing that, we should have a more stable idle by retarding the intake and advancing the exhaust, which is what we're doing by moving them a tooth, essentially. I don't like the idea that a tuning error can result in just completely destroying the motor. So I think I'm going to advance this. I'm going to go ahead and advance this by one tooth. No, sorry, retard it by one tooth. I mean, the good news here is it'll let me see what the idling characteristics are, because what we're doing here essentially is what the Atkinson cycle is by pushing that 20 degrees. But we'll be able to get out of Atkinson mode, no problem. Where'd my grenade pin go? Now, it should be impossible. But we're going to check it anyways. And yeah, the cam's free. Cam's free, it's fully advanced. And let's see how much travel we've got. Oh, yeah, I'm not going to measure that with an indicator. That's at least 1/8 of an inch, which is, I mean, that's enormous. We don't need anywhere near that much. But, I mean, that was expected, right? Because we were having a collision here at 3 or 4 degrees, and we moved it by 20. So, all right, so we have our spec. We're essentially retarding this by 1/2, so 20 degrees, and advancing this by 1/2, 20 degrees, which is just basically reducing the maximum amount of overlap that we can have because our overlap was touching. So that will cut out some mid-range power, but at the top of the range, most of the VVTi stuff is dialed out anyways, so that shouldn't affect the top of the power. And if I can see that it's requiring the maximum amount of advance and the maximum amount of retard at max power, then we can tell, okay, well, maybe we need some more, and we can evaluate that at that point. But what we have here is a motor that mechanically is unable to crash no matter what we do. So I like that idea. At this point, we know everything we need to do to time the motor. Now, I need to do a little bit of measuring that I'm going to do off camera, though I'll give you the results, on if the stock springs will actually handle this much travel. But regardless of if they handle it or not, I called SuperTech and they saved the day. They actually got these to me. I called them, I said I screwed up, I forgot to order, and they got them to me in 3 days. So yay for an automotive aftermarket supplier that actually has parts on the shelf and ships them quickly. So regardless of if they fit or not, I will be using those. The reason for that is I want to be able to, if this thing gets to 7,200 RPM, which is roughly the limit for these factory springs, and it's still building power, I want to be able to just push it further. Those springs are not ridiculously heavy, so they might cost 1 or 2 horsepower, but even the dyno chart that we'll get will be valid whether or not you have them in there. Now, give me a minute, I'll be right back, and I'll tell you guys if the factory springs will work or not. You know what? I was expecting to have to do the math to see if it was worth it or not, but we hit coil bind. So, coil bind means that I don't have to do the math, which is a good thing. But it means that these will definitely not work with stock springs. So let me go ahead and put the SuperTech springs in, and we'll go from there. That's an absolute joy, changing springs on a motor. All right, so I finished all the springs last night, and you can see, yeah, this took me about an hour and a half, maybe 2 hours. It's a massive pain, but it's nice that I don't have to disassemble the motor any further than this to get to it. From here, we've got our little and our big torque wrench, and we're just going to put everything back together. We should be good to go. Couple notes. I'm going to go ahead and leave this on for now because you don't need it to assemble the motor, but it just makes it easier, right? Because I know exactly where it is. In order to get the cams on, what I'm going to do, I'm going to put it at about 90 degrees. And that way I know no matter what position I put the cams, I can rotate them. The pistons are all halfway down, so I don't have to worry about anything striking anything, which can matter when you're torquing things down. You can actually bend a valve. So yeah, I guess it's time for another time lapse then, isn't it? all the steps before this, I wasn't nervous. Everything was just going together exactly the way it should. Exactly the way car parts should fit, but we're about to fire this thing up. And this is a big milestone because the parts in there are the first custom parts that I've gotten made for engine internals. Not talking about ordering something custom, like it, everything, the position of the lobes, the size of the journals, every last thing, the exact shape of the lobe on these cams is my design. And to top it off, they're asymmetric because it's what the math showed should be needed. I'm so damn nervous. The RTV is set enough, set enough that it's not coming off on my finger. So right now, the Outtake still got the original tune that I had on there. It probably needs some changes, but I don't know exactly what they are, so there's no reason not to. I expect it to fire up in idle. I don't know how clean that idle will be, but since it's mass airflow system, it should compensate for a whole lot of this. And the exhaust is open right now. There's no O2 sensor, so there's no feedback as far as that goes or anything, but it's not going to run for long enough. The only consideration I've done is the two VVTi solenoids are currently unplugged. I don't want those to move around right now. So, shall we? First we gotta start the fuel pump. All right, here goes. Did I mention I love variable valve timing? I turned the lights off there. Oh, let me turn this pump off. I turned the lights off there because I was seeing a lot more flames, and that's not unexpected given the timing of the whole thing. But that was a relatively smooth idle. I have no idea what RPM that was, but all right, durability has to be tested, but it runs. It runs. I'm so excited. I don't know. I don't have anything else to say. We'll see you guys in the next one. It's probably going to be dropping this thing in the race car. It's probably going to be the white 3rd gen MR2 because Evey is not quite ready to receive an engine yet. Yeah, that's it. Have a good day. Yeah! Oh, I don't have lights on. Damn it. I spent all that time talking and I didn't have the lights on. Oh.